All right, hello. Welcome to Unit 9, Skill 3, Level 2 again, but now Part 2. We're going to focus now on difference of squares. This is a very special and specific case. This is only going to work for binomials only. Okay, so let me write that down. So, binomials only. So you'll notice that on this page of notes, every single one of these has two terms. Okay. And the other key to point out here is that difference means subtraction. So that means that this is only going to work for binomials that have a minus sign in between and squares, perfect squares. So like x squared is obviously, x times x. 9. We're trying to think of numbers that multiply to 9, but the same number, like 3 times 3 would multiply to 9. 4 times 4 would be 16, okay? In other words, if you're familiar with this, it's kind of like square roots. All the numbers that we see here, 9, 16, 25, here's another 16, 9, and 4, those have square roots, okay? Otherwise, difference of squares will not work. Okay, so here's the pattern. Okay, so basically the difference of squares formula starts with something squared minus something else squared. So I have a squared minus b squared. Okay, and the way it's going to factor, it'll be a minus b and then a plus b, always. Okay, and if you're not sure why that works, this isn't just a magic trick or a formula. I mean, if you multiply this back out, so like a times a, that gives you a squared. A times b gives you positive ab. Negative b times positive a, that gives you negative ab. And then negative b times positive b, that's going to be negative b squared. And so you can see right there, the middle terms cancel out. Usually we combine the middle terms to make it into a trinomial, but in this case, all we're left with is just the a squared minus the b squared. So anytime we have this pattern, we can always go back to this. Okay, so here's how you could apply this in number 1. Okay, so first you could rewrite x squared minus 9. You kind of want to go, okay, well, what am I squaring to get x squared? And what am I squaring to get 9? Okay, so obviously the first one's easy. It's just x squared, okay? And then if you're not sure what squared equals 9, again, think square root, or think what number times itself is this number, and that's going to be 3 times 3. Okay, so that'll be x squared minus 3 squared. Okay, and so according to our pattern that we just kind of proved basically and verified, this number in the parentheses, that's kind of like the a that we see here. So this is your a right here. And this number in the second parentheses, that's the b that we see up here. Okay? And so you're just going to follow the pattern. A minus b, a plus b, that means one will be x minus 3 and the other will be x plus 3. And it's that simple. Okay? Let me do number 3. Okay? So number 3, again, you first think of it as what squared minus what squared is 16. Well, I know n times n is n squared. I also know 4 times 4 is 16. Okay? And then following the pattern, this is the a, this is the b. You're just going to go n minus 4 and then n plus 2. It's always, oh, sorry, I don't know why I did 2. That should be 4. It's always going to be the same number. One is minus and one is plus. Okay, and that's the difference of squares formula. All right. Now, interestingly enough, you don't have to write this down, but it's worth mentioning because you could kind of treat this like the previous problems where we had trinomials, but what you would do is you rewrite x squared minus 9 as x squared plus 0x minus 9. And then you can kind of think, okay, well, what multiplies to 9? So that we have 1 and 9, 3 and 3, but has to add up to 0. In other words, cancels out entirely. Well, the only way that that would make sense is if we have the same number and one is minus, one is negative, and one is positive. And there you go. So there's another way to think about it. X minus 3, x plus 3. Okay, but again, once you get more experience and you're more of a veteran because you've done algebra for a few years or maybe even just a couple of weeks with the factoring, you're probably not going to think of it like this. You're going to go, for example, like let's do number 5. Number 5, okay. I see a binomial, I see subtraction, and I see squares because 9 and 4 and the r square, those are all squares. So I'm going to immediately think to use this difference of squares technique or pattern. And so 9, I know that 9 is the same as 3 squared because 3 times 3 is 9. And if I'm trying to create 4r squared, I know that 2 times 2 is 4, and obviously r times r is r squared. And so you could rewrite it as 3 squared minus 2r squared. And now you just fill it in. 3 minus 2r times 3 plus 2r. And then you're done. Okay? Now, as you get more comfortable, you might not even do all these little steps here. You might just go, let's do number 4. Oh yeah, difference of squares. Okay, because why? This is a binomial. I see n squared, and I see 25, and I see subtraction. So everything is good. And so I know this will be n minus, this will be n plus, always. And then 25, I know that 5 times 5 is 25. And I'm done. Okay? So that's kind of how that works. It's also worth mentioning one more detail. And that is, let's look at number 7. This is a square, because you can do b squared. The 9 is a square, because you can do 3 times 3, so 3 squared. But notice that we have a plus sign, okay? This does not factor. In fact, this never will. Okay, so anytime you see squares but separated with an addition sign, that's always going to be not a factorable expression. So you just write not factorable. Okay? All right, so that's a little bit about difference of squares. Again, that only works for binomials, and it works if there's subtraction and everything is a square. Okay? All right, hopefully this makes some sense. Fill out the rest, try the rest on your own. Again, you can multiply things back out to check your work and make sure that it is correct. For example, if you took n times n, if I wanted to check number 4, n times n is n squared. N times positive 5 is 5n. Negative 5 times n is negative 5n. And then negative 5 times positive 5 is negative 25. And right there, you see the middle terms go away. And you're left with n squared minus 25, which is exactly what we started with. Okay, so you can check on your own, but check your answers with our answer key so that you can be 100% sure that you're getting it and moving on. All right.